today we are going to talk about matrix. First, we have to define what matrix is. Okay, matrix is a rectangular array or arrangements of numbers in rows and columns. Okay, a matrix is any arrangements or arrays of numbers in horizontal and vertical lines. So the horizontal arrangements are said to be rows and the vertical arrangements are called the columns. Okay, most of time matrix is denoted by capital letters like A, B, C, D. Okay, matrix A is given by the first entry of the matrix or the first row and column is given by A11, A12 up to A1n. Okay, the second row and the first column is started by A21, A22 up to A2n. Okay, up to AM1 up to AM2. Okay, up to AMN. Up to AMN. So matrix is, as we have said, it is an arrangement of numbers or arrangements or arrays of numbers in horizontal and vertical arrangements. Before we are going to deep into operations and another calculations on matrix, we have to define some important types of matrix and terms of matrices. Matrix, the arrangements in horizontal and vertical lines have each elements, so the elements are said to be the entries. So each entries in a matrix is called elements of matrix, and elements in the horizontal lines are called rows, and elements in the vertical lines are called columns. Before we proceed to another important part of matrix, which is operation of matrix, we have to define some important or types of matrix. Because the first one is matrix can be classified as column matrix and row matrix. A matrix with only one column is called a column matrix. In the other way, a matrix with only one row is called row matrix. So vector matrix can be a column matrix or row matrix. Another important term or type of matrix is a square matrix. So a square matrix is defined as it is a matrix with the same number of columns and rows. With the same number of columns and rows is called a square matrix, which means horizontal arrangements of numbers is equal to vertical arrangements of numbers. Okay, another important term in matrix is zero matrix. Zero matrix is a matrix with all entries zero, which all elements zero. Okay, another important term in matrix is the diagonal matrix. Okay, diagonal matrix is first, it is a square matrix, so it has a zeros everywhere except the possible along the main diagonal, or all elements except the main diagonals are what? Zeros. Okay. Another important term in matrix is scalar matrix. Okay, scalar matrix is a diagonal matrix. It is a square matrix where all elements of the principal diagonals are equal. For example, A is equals to 1 0 0 0 1 0, okay, 0 0 1. Okay, this is such or a kind of scalar matrix where all elements in the main diagonals are what? Equal. This is a bicycle matrix where the elements in the main diagonals are equal, which is 1. So such type of matrix is called a scalar matrix. Okay, another important term is a triangular matrix. Triangular matrix. Triangular matrix can be classified as lower triangular matrix or upper triangular matrix. Lower triangular matrix is a square matrix. It is a kind of diagonal matrix where the elements above the main diagonals are all zeros. Okay, lower diagonal triangular matrix is a square matrix whose elements below the main diagonals are all zeros. We proceed to another important type of matrix, the identity matrix. Identity matrix. Okay. In arithmetic, algebra calculation or operation, for example, in addition, if we add zeros, no consequence or influence on the result of the number. So 0 is, in arithmetic operation, it is additive identity. Additive identity, which means in the operation it has no any influence. When you come to multiplicative identity, in operations of multiplication, if any number is multiplied 1, it has no influence on the result of the number. So 1 is the multiplicative identity in multiplicative operation. So when we come to matrix, the identity or unit matrix is a diagonal matrix, a type of diagonal matrix or a type of square matrices where the elements of the principal diagonals are all ones, which means if we multiply a matrix with any identity matrix, it has no any influence in the result of or in the operation of the matrix. As we have said in our arithmetic operation, 1 has no any influence in the result of multiplication. So in matrix, identity matrix has no influence on the multiplication of any matrix. Okay, in determining matrix A is equals to Aij, which is 2 by 3 matrix, is equals to J minus I. Okay, matrix A is given by, it is 2 by 3. So the first entry, which is the first row in the first column, is A11. So A11 means the value of J is 1 and the value of I is 1. So J minus I is 0. Okay. A12 means the value of J is 2 and the value of I is 1. So 2 minus 1 is 1. A13 means the value of J is 3 and the value of I is 1. So 3 minus 1 is 2. Okay. A21 means the value of J is 1 and the value of I is 2. Then 1 minus 2 is -1. Okay, 8 to 2 means the value of j is 2 and the value of I is 2. 2 minus 2 is 0. 8 to 3 means the value of j is 3 and the value of I is 2. Then 3 minus 2 is 1. So the matrix is given by 0, 1, 2, -1, 0, and 1. Okay, thank you for watching.